This series of videos will be about section 5.3, exponential and logarithmic equations in the book College Algebra in Context. Solving exponential equations using logarithmic forms. To solve an exponential equation using logarithmic forms, first rewrite the equation with the term containing the exponent on one side by itself on one side. Divide both sides by the coefficient of the term containing the exponent, change that new equation to logarithmic form, and then solve for the variable. Here's an example of that. We're going to take the equation 3,500 equals 250 divided by 10 times 3 to the t. The t's in the exponent. First thing we do, we've got the exponent term on one side by itself. We're going to divide by the 250. When we divide by that, we find out that 14 equals 10 to the 3t. Now we change this to log form. My base is 10. So my base is 10. Log base 10 of 14 equals 3t, and t then can equal log of 14 over divided by 3. This is the exact answer. When I use my calculator, I can find what that, if I use my calculator, I can find what that equals. But this is the exact answer. Using the calculator, I find out it is 0.3820 to 4 decimal places, which is fairly standard using logarithms. Prove the time it takes an investment to double its value is t equals ln of 2 divided by r if the interest rate is r compounded continuously. Well, compounded continuously, you remember the equation as s equals p times e to the rt. And we want it to double, so say p was 1, we want it to double to 2, 1 times e to the rt. So I've only got 1 there. I now can change this to exponential form. So the log of 2, this is base e, and the exponent is rt. So t then equals ln of 2 divided by r, just like they said it would. This is base e, and the exponent is rt. So t then equals ln of 2 divided by r, just like they said it would. Now, suppose we have $2,500 invested at an account, in an account earning 8% annual interest compounded continuously. How long will it take the amount to grow to $5,000? Well, with the time then is ln of 2 divided by the interest rate, which is 0.08. Again, this is the exact answer. The approximate answer, when I grab my calculator, is 8.66 years. The change of base formula. We can use a special formula called the change of base formula to rewrite equations so it is in either base 10 or base e, and those are the only two bases we have on our calculator. The general form for the change of base formula is summarized below. So the base is greater than the base is greater than 0, not equal to 1. A is another base greater than 0, not equal to 1, and x is greater than 0. So log base a of x equals the log base b of x divided by the log base b of a. for base 10, log base a of x is the log of x divided by the log of a, or log base a of x is ln of x divided by ln of a. So here, let's actually do this. So to find this, we'll take the ln. It's log base 9 of 145. So the log of 145 divided by the log of 9. And then we grab our calculator and find out that it's 2.2650 to 4 decimal places. And here we would take the log of the cube root of 45 divided by 4. So I can do that with my calculator and end up with 0.9153. And I'll show you then how to do those actual divisions on your calculator. Log of 145 divided by the log of 9. And you can see we get 2.26500, and we would normally find these to the nearest 4 decimal places. So 2.2650. The next one, we have the log base 4 of the cube root of 45. So that may be little extra steps to get this. So we'll have to take the log of the cube root. So go to Math and do number 4 for the cube root of 45. And we'll come out of the parenthesis, out of the radical and close the square root, divided by, it was base 4, so the log of 4. 0.91530, so 4 decimal places, 0.9153.